Static pressure is the force of fluid particles on the walls of their container. It really doesn't matter whether we have a flow or not, we always have this static pressure. The velocity pressure is another form of expressing kinetic energy of the flow. An example of the velocity pressure is the force of air on a car when it's moving. Let's look at an example of total pressure change in a duct system that has a fan in it. Starting from the left, the suction opening is at a relative negative pressure. This negative pressure forces the surrounding air to flow toward the duct opening and then gets sucked into the ductwork. As the air moves inside the duct, it loses its total pressure due to friction. This pressure loss happens faster when the air moves inside the smaller ducts or wherever the resistance to the flow is higher. Once the air enters the fan, its total pressure starts to increase until the air leaves the fan. In the supply ductwork, the air's total pressure starts to decrease again because of friction. At the end of the supply duct, where the air leaves the ductwork, the static pressure is zero. This is because the air is entering an environment that is at atmospheric pressure. Note that the total pressure is not zero yet because the supply air still moves and has some velocity pressure at the supply opening. But this velocity pressure eventually becomes zero at some distance away from the supply duct opening. Make sure to study this diagram because it is critical to understand the concept of total static and velocity pressure change in a ductwork.